Hey guys, welcome to lesson 8.1, where we start discussing hypothesis testing. So when it comes to estimation, we looked at confidence intervals. For a confidence interval, we looked at a range of plausible values for something. So for example, we will start with a sample statistic. And then we say, well, all right, we don't think our sample statistic is exactly that. So we go a little bit to the left of it, little bit to the left of it, a little bit to the right of it, and we say, all right, we think it's somewhere in a certain range. Now, for hypothesis testing, we have a claim about a population. So, for example, proportion of students who keep their car on campus. The claim is that it's 55%. But then we have data, and our proportion of students in our sample has 60% of students who keep their car on campus. And the question is, given our sample statistic, is our claim still believable? So let's look at an example of a student named Alex, and Alex is taking a class, and Alex did exceptionally well on a final exam, got a 97. Now, the first 5 exams, Alex averaged a 74 and never got above an 85. And then he crushes the final exam, misses like one question. So the instructor refers Alex to the honor court. And of course, Alex is presumed not to have cheated. So we have this idea of innocent until proven guilty, right? It's on the instructor to demonstrate that Alex, in fact, did cheat. So when the honor court decides, they're either going to rule that it's Alex is in violation or not in violation. So he'll never be proven to have acted honestly. He either proves there's proof that he cheated, or there's not enough proof that he cheated, right? So, all right, in this example, we presume Alex did not cheat. And when we set up hypothesis testing, we've got 2 hypotheses, the null and the alternate hypothesis, and we'll talk about that in a second. And we assume that our null hypothesis is true. In the honor court, the instructor presents the evidence, and for hypothesis testing, we collect data and then we examine the sample statistics. How unlikely is the evidence? So we say, all right, if Alex is in fact honest and telling the truth and didn't cheat, how unlikely is this data that we collected? So same thing with a p-value. The idea with a p-value is, given our sample data, how likely is it that the null hypothesis is true? And then the ruling is either in violation or not in violation. We reject the null or we fail to reject the null. And we're going to do a lot more with the kind of formal hypothesis testing, but this is the general setup, right? There's an accusation. Alex is presumed to be innocent. It's presumed that he didn't cheat. I think it's a good base assumption. And then all the evidence is presented, and it's like, how likely or unlikely is this evidence if he did not cheat? So 5 steps. We state the null and alternate hypotheses, the null and the alternate hypothesis. We check the conditions. We compute the test statistic. That's basically like presenting the evidence. We find the p-value. P-value is it's a probability, and again, we'll talk more about that later. We either reject the null or fail to reject the null. So we say, all right, there's enough evidence to conclude that Alex cheated, or there's not enough evidence to conclude that he cheated. And then we report the conclusion in plain language. So for lessons 8.3 through 8.6, we're actually going to get into the nitty-gritty of the calculations. 8.1 and 8.2 are more the theory behind how all this happens. All right, so 2 competing claims. H sub naught, so it's H with a little 0 written underneath. It's called the null hypothesis. Basically, nothing is happening, status quo, no change, no effect. Basically, it's like the assumption that Alex didn't cheat. I think if anytime a student takes any sort of exam, the assumption is they're not cheating, and there has to be compelling evidence to kind of have an alternate hypothesis. So something is happening, the claim the accuser or researcher hopes to establish. So here, the assumption is he didn't cheat, there's nothing going on, but as we gather evidence, we might question that assumption. So, getting a 97 on the final exam when so far Alex has been a 74 average student, that's like a reason to pause and kind of give everything a closer look. So hypotheses are about parameters, never statistics. So the null hypothesis could be like the proportion of the population is 0.55. The mean of the population is 1.75, right? So it's never going to be, so p hat is sample proportion. And for example, x bar would be sample mean. And we can see both of those. Those come from the sample. So there's nothing uncertain to test about them. But we're interested in a population. So just as the panel asks what Alex did, not what the exhibits look like, we know what the evidence is. So we know Alex got a 97 on the final. But the question is there like a underlying evidence? Does that lead us to conclude that, he must have cheated? That's the idea. So writing the hypotheses, cars on campus parking claims 55% of undergraduates keep a car on campus. Student government suspects it's higher. The null is the assumption that it's 55, but we have the suspicion that it might be higher. Hours of sleep, a wellness page claims students average 7 hours of sleep. We don't think that's true, which means it could be more, it could be less. We would present that as not equal to. By the way, whenever you have an alternate hypothesis with a greater than or less than, that's called a one-sided hypothesis. If it's a not equal to, that's a two-sided hypothesis, and we'll get into more the nitty-gritty of that later. So one-sided or two-sided, the alternate hypothesis, parameters greater than value, more than greater than increased majority, that's one-sided to the right. If it's less than the value, it's one-sided to the left. And if it's not equal to, different from change, not equal to, that's a two-sided hypothesis. So Alex's case is one-sided in spirit. No one is accused of cheating their way to a lower score. So the idea is that, he scored higher than his average. So D2 claims the mean wait time at the stir-fry station is 12 minutes. You suspect it's longer, right? The null and alternate hypothesis. All right, so HOHA. This has to do with the mean wait time, and we suspect the mean wait time is 12 minutes, but their stated wait time is 12 minutes, but we suspect the wait time is longer. Remember, we're not writing X bar. That would be that's the sample mean. We're interested in the population mean. Bikes on campus. A report claims 40% of Virginia Tech students bring a bike to campus. All right, so the claim is the proportion of all students is 40%. You doubt the figure but have no direction in mind. All right, so we think that it's actually not 40%. Spot the error. A classmate writes, they write that the null hypothesis, X bar is equal to 12. Why is this wrong? The reason it's wrong is they're using X bar. So X bar is the sample statistic, sample mean. But what we actually want is we want the population mean. We want the mu for that. Alex's hearing. State the null and alternate hypothesis case in words. So the null, Alex did not cheat. The alternate, he did. Which honor court ruling corresponds to failing to reject the null? So if there's not enough evidence, then we basically say we don't have enough evidence that he cheated. If there is enough evidence, we say there is enough evidence that he cheated. We never actually prove that he didn't cheat. There either is enough evidence or there's not enough evidence to conclude that he cheated. So key terms, null hypothesis, nothing is happening, parameter null, assumed at the start. That's the key about the null hypothesis. Alternate hypothesis, that's the claim the researcher hopes to establish, and they better have good enough evidence to show that. The null value, specific number in the parameter, is claimed to equal the null. By the way, the null hypothesis for us is always going to be some sort of equality. And the alternate hypothesis is always going to be some sort of inequality, less than, greater than, or equal to. One-sided test, the alternate hypothesis points to the left or to the right. Two-sided test, it's a not equal to. So same stuff. The null is always an equality about a population parameter. That's the key. HA is a claim someone hopes to establish. The hypotheses are never about p hat or x bar. The statistic is visible. It's the parameter that we're curious about. The wording of the question sets the sides. Directional words give one-sided tests, different from gives two-sided tests, and the evidence against Alex is weighed in lesson 8.2. So in 8.2, we're actually going to look at the evidence and we're going to make some sort of conclusion.